that was when the River Thames froze over every winter. And it was so cold that there were poor crop yields in parts of Europe. There was starvation. It went on for 65 years or so. Our friend Galileo had invented the telescope in 1610, and one of the things he started doing was looking at the sun, not directly but indirectly looking at the sun, and he discovered sunspot activity. Sunspots. He didn't know what the hell they were. They were just there, blobs of stuff on the surface of the sun. And they were big. They could see these things. They were discernible. So he monitored them, and he recorded them. And he kept a pretty good record. And other scientists of the day, when they bought their telescopes, look at the same thing. Why not? It's a good topic. They do this sort of thing. So they kept a pretty good record. And so we have a record of sunspot activity that goes back 400 years. And coincidentally, that record travels the temperature rise better than does the CO2. So there's a theory that says that when we have sunspot activity, it adds energy to our system because it blows away cosmic particles that are impacting the Earth and forming clouds. This may or may not be true, but it's a logical sort of correlation. If there's times when there's low sunspot activity, we have what appears to be some cooling. If you look in the 1970s, that's the case. If you look in the last 10 years, the same case. We've had very low sunspot activity for the last 10 years, and the temperature seems to be dropping. There was the famous emails from the leaked emails last fall where they were talking about the decline. That we can't explain the decline. And it's a tragedy that we can't explain. Well, the decline is the fact that the temperatures seem to be going down, even though there's been speculation that this has been a very hot year and that sort of thing. But they were coming to the conclusion that there has been a decline and that they can't explain it. But it could be explained by this theory, if this theory holds, that sunspots cause fewer clouds and therefore more solar heating. On the other hand, if there's no sunspots, there's more clouds and greater reflection of sunlight and less heating. And that's one of the other things that we have to talk about. Now, if in fact we do have clouds and we're heating the atmosphere, the question is, what can we do about it? Is there any way to mitigate our effect on the atmosphere for sustainable life for the future, no matter what happens? And there are a couple of things that could be done, one of which makes more sense than the other. We could try transferring heat to the oceans to heat them up a little bit. And that would give us time to develop a rain or a cloud forming process. Now, other people have suggested that aerosols, particular sulfates and sulfur trioxide, are good agents for high-level cloud formation because they are very hygroscopic. The problem with that is that it forms slight amounts of sulfurous acid, which is not so good for the environment. But the same thing could be done if we use, instead of sulfur trioxide, we use anhydrous ammonia, NH3. Simple gas. We know how to make it. There's lots of it. And that stuff is so incredibly anhydrous that if you released it in the upper atmosphere, you'd get virtually instant cloud formation. If we started experimenting with using anhydrous ammonia now to see how effective cloud formation could be, we'd be able to learn enough about doing it that we'd be able to pretty much geoengineer the right amount of cloud formation, the shade that we need to counter the energy that we're putting into the atmosphere. We need to balance it with the sunlight that we need for plant growth, vegetation, all of the things that we need. But this insanity of this cap and trade and not understanding the combustion energy problem as opposed to the greenhouse problem is what's going to be the ruination of our society as we know it. And I can't predict which way it'll go. All I can do is present my ideas, and if people think they're valid, they can check out all of my information. My website has all of the calculations, all of my blogs, everything is linked to my website. And if you look at that, you can learn more about what I think about this sort of stuff. So that's what I have to say about the greenhouse gases and that sort of thing. But now I'd like to speak to you about my other favorite topic, and we're running a little late. Oh, geez, I didn't know I was talking that long. Boy, gift of gab. I was born with it. Incineration of garbage. Not just garbage. Renewables. Or not renewables. Recyclables. Paper and plastics. You know, other mayoral candidates think that we should just bury this stuff and leave it there. You know, you bury all of our garbage, and for about 20 years, it generates methane. The methane is captured and is used to generate electricity, which is fine and dandy. But that only takes out, the methane only comes from the organics, from the carbohydrates, from the fats, from the proteins that are thrown out by people. And that's all it is. The plastic, the polypropylene, the polyethylene, the butyl hydrates, the methacrylates, all of that stuff doesn't decompose whatsoever. It just stays there. And it'll stay there for 10,000 to 100,000 years because no bacteria, no organism has yet developed to learn how to chop it up and eat it and digest it and turn it into an energy source. So, I suggest that we burn the stuff, all of the recyclables, all of the garbage, and turn it into electricity. Based on my calculations, I figure a ton of garbage is worth about $350 worth of retail electricity. You know, Toronto Hydro sells it to the homeowners, they pay $350 for it. That is a lot of money. We also saved $100 million of transport costs associated with it. We saved the $25 to $50 million worth of recycling programs that we have, where we're trying to recycle this material, and people are just going broke, taking on these projects and getting paid money by the city to do it, instead of putting it to a good use as a secondary source of energy. Instead of burning a kilogram of oil or a kilogram of coal, we burn a kilogram of garbage, and we get the same amount of energy out, and we profit from it. So it reduces the city debt. The way to do it, in my opinion, and it's just my opinion, I'm not a total expert on this, there's other people who have other suggestions, but if you take the exhaust gas from any incinerator, any generator, and you bubble it through water, it cools the gas, first of all, and it takes out all of the particulate and contaminants that are quite soluble in water. So you don't have any of the toxins flying off that are going to contaminate the atmosphere. And you take that collection of water, which would be probably more than enough to fill this room 3 or 4 times, and you keep reprocessing it, taking out the contaminants, because it's easier. It's so concentrated in the water that it's easier to deal with the toxins in a concentrated system. So you then recycle that water back to cool more water. You keep doing this process, and you keep recycling lake water through heat exchangers into that water to take the heat that you captured from the exhaust gases and dump it in the oceans. So it kills 2 birds with 1 stone. You make money off of the garbage. You save landfill. You detoxify landfill, and you heat the oceans a little bit. And we have a lifestyle that is beneficial as far as I'm concerned. So that's my theory on the what we're doing wrong, why we're doing it wrong, and what we need to do to make it better. So if anybody has not understood anything, I'm open for questions, and anything goes.
What's your website?
www.selwynformayor.com. I have business cards if you like one.
So where do the toxins go end up eventually?
Pardon?
Where do the toxins end up?
Well, the toxins would eventually be collected and end up in various ways of detoxifying, converting them into insoluble materials and putting them by making them into inert materials that aren't going to be dissolved anywhere. Right now, the toxins that we're talking about go into landfill. They stay there, they migrate out from time to time, and things like that.
And is that kind of process?
Pardon?
Is that kind of process very expensive? The process of disposing of those toxins in that water safely, would that be taken up?
It would be taken up by we're getting money out of the incineration. Whatever it takes to detoxify it would be only a small percentage of that. We might not get the full value out of the incineration, but we'd be able to do it very cleanly, very well. I've worked with in pollution abatement programs where they were bubbling gases through solutions to concentrate the contaminant and decontaminate the gas. So the technology is there. We have this stuff. It's just a matter of applying it, and that's the main issue we have with how we're dealing with the toxins. But by doing the same old stuff, throwing them in the ground and leaving them there for 100 years, 1,000 years, or whatever, they eventually get into the water system, and we end up suffering. You know, this is what's been happening. The Pan American Village area downtown is loaded with contaminants. And they're still trying to figure out what to do with it, and they can't, because they don't understand what needs to be done. And they won't listen to people like myself or professors here at the university who do understand, because they have this rabid idea that we're just lunatics and we don't know anything, and so they don't want to even try. But that's the issue with this stuff. It's better to concentrate it in a system that you can deal with effectively. You can't take all of the toxins out, but you'll be collecting toxins and you'll be keeping them contained within that volume of water. And over time, you'll be able to take more and more toxins out. But it's not going to ever be that you've got pure water that you're recycling back into the system. That's not going to be the case. But we have ways of dealing with it, and that's the important thing.
You talking about wind power.
Yes, I did briefly.
You said that because the wind wasn't efficient, it wasn't 100% efficient, some of the energy would just disappear.
No,
it doesn't really fit with what with the law of conservation of energy. The implication was that use of wind power would cool the earth because some energy would just disappear.
No. The energy wouldn't disappear. There would be energy that it all has to go back into the system. But depending on how you set up the generators, whether it would all go back in, or whether you would, if you use water-cooled generators, then you could be heating the water with the excess energy that you weren't getting out of the wind. I didn't specify that, but this is what would happen. I mean, basically, it's a balancing act. You can't get more out than you put in.
Have you ever looked up how many cities around the world do burn garbage, do incinerate garbage to generate electricity?
There's almost all cities in Denmark do. They have laws in Denmark that you're not allowed to bury anything that can be